video is on the Chinese remainder theorem. So our goal is to solve linear congruency. Now, I have this format here. X is congruent to B1 mod N1. So if I put the actual value, it would be X congruent to 3 mod 5. And then X is also congruent to B2 mod N2, which is going to be, I substitute values for those. X would be congruent to 1 mod 7. Therefore, X is also congruent to B3 mod N3. So X is 6 mod 8. So if you look at this, we're trying to solve for X. X has this different scenario. Now, we're looking at N, which is going to be N1, N2, N3. Don't forget, 5, 7, 8 have to be co-primes. They have to be, co-prime means that if you take the GCD of any two of them, the GCD has to be 1. So when I multiply 5 times 7 times 8, I get 280. Now the goal is to take the summation b sub I, n sub I, x sub I mod n, and that should give me a value of x. Let's go ahead and expand on this. So I'm going to write b sub I, which is going to be b1, b2, and b3. Now b1, b2, and b3, that's going to be 3, and that's going to be 1, and that's going to be 6. So these are the values for b1, b2, and b3. And therefore n1, n sub I is going to be n1, which is n1 times n2, or uppercase n1. So if I take n1 and n2, so therefore this is n1, this is n2, and that's n3. So n1 would be 5 times 7, and n2 would be n1 times n3, which is 5 times 8, and n3, which is going to be n1 times n2, which is 5 times n2, which is 7. So you see, we had all these different combinations. 5 times 7, 5 times 8, 5 times 7. So this is already repeated. So n1 and n2, so this cannot be, so this should be n2 and n3. Okay, that was a mistake. So if I do n2 and n3, it's going to be, n2 is going to be 7, and this would be 8. Okay, so now I got all different combination. Now I'm going to have to figure out what x1, x2, and x3 is, and I will somehow evaluate them. B sub I, n sub I, x sub I, this is x sub I, so it will be b sub 1, n sub 1, and n and x sub 1. So let's look how we did this. So I'm going to take each congruent equation here. This is going to be n1 times n2. So 5 times 7, okay. So if I do 5 times 7, that gives me 56. So 5 times 7 is 56. So for the first two, it's going to be 5 times 7. Okay, so, okay, I did 5, okay. So this would be the two numbers there. So if I get x1, which is going to be 56, how did I arrive at 56? It's going to be 7 times 8. So I take 7 times 8, that gives me 56x1. So 56x1 is congruent to 1 mod 5. If I take 56 modded by 5, 56 mod 5, that gives me 1. So this is actually 1x1, 1 mod 5. 1x1, 1 mod 5, therefore x1 is 1. So we solve for x1. Now for the second one, so it's going to be n1 times n2, so 5 times 8, which is 40. So 40x2 is 1 congruency, it's congruent to 1 mod 7. So if I take 40 mod 7, the answer is 5. So look at this. So I need a number which I can, so that would be 5x 1 mod 7. So what should I do? Here I need a value multiplied by 5 modded by 7 should give me 1. So look at this. Any factor that I can multiply by 5 modded by 7 should give me 1, because the coprime, the GCD has to be a 1. So when I multiply this by 3, that gives me 15. 15 mod 7, the remainder is 1, so modulus 1, so therefore x2, since I multiplied it by 5, multiply this value here, the 1 by, I multiplied the 5 by 3, the 1 needs to be multiplied also by 3. So therefore x2 is 3. So now I got a value for x2. x2 is now 3. So let's continue. Now for the third equation there, 5 times 7, which is x3, 5 times 7 x3, so that would be 35 x3 is 1 mod 8. 1 mod 8. Now, so if I take 35 modded by 8, that gives me 3. See that? So that actually gives me 3. Now, I need a factor, I need a term. Multiplied by 3, modded by 8 should give me 1. So if I multiply 3 by 3, that gives me 9. Mod 8, which is 1. So since I multiplied this term by 3, I'm going to multiply this term by 3. So this would be x3 congruent to 1 mod 8. So therefore x3 is 3. So now what do I have? I have x1, which is 1. I have x2, which is 3. And I have x3, which is actually 3. So now I got to go back to my original equation here, and I'm going to sum these and see how I can come up with the answer. So let me go ahead and erase these values here and try to plug it in, since I know what the values for x1, x2 and x3 is. So if I look back here, okay, so if I look back, let me go ahead and try to do this. So it's going to be b sub 1, n sub 1, x sub 1 plus b sub 2, n sub 2, x sub 2 plus b sub 3, n sub 3 and x sub 3. So let's see what those values are. So b sub 1 is 3, all right. N sub 1, which we figured earlier, and that was 56. Okay, and then x sub 1, x1, sorry, is 1 plus. Now b sub 2 is actually 1, and then n sub 2, that was 40 according to our previous equation there, and then x sub 2 is actually 3. That's a 3. Therefore b sub 3 and b sub 3 is actually 6. So this is 6, and n sub 3 according to our previous value, that was 35, and then this is 3. Now all I have to do is evaluate these. Now when I take 3 times 56, that gives me 168 plus 1 times 40 times 3, that gives me 120 plus 6 times 35 times 3, that gives me 630. So summing all of these three values, so if I sum these, I'm going to end up with 918. Okay, so I can move forward now. So what I'm saying is that x is actually 918, 1 mod, see, and what is the big N here? That's 280. So this is 280. Okay, so I end up with, so if I take 918, mod it by 280, that gives me 78. So this is 78. Okay, So I can actually take 78, and you know, if you do 1 mod 280, so in reality here, x is gonna be 78. So this is how we solve for x. And we could go back and test these, and you know, I could have done this here for each value. In fact, we could have said 78. This is how you can confirm it's 1. 78 is 3 mod 5, and then if you solve you get the same. So 78 is going to be 1. So this one is mod, so this is mod 7, and 78 is going to be 6 mod 8. So this is how, if you want to verify the answer, that x is actually 78. So this is solving a linear congruency using the Chinese remainder theorem.